How do isolines help read physical maps? Have you ever looked at a physical map and wondered how to make sense of all those lines and shapes? One of the key features on these maps is isolines. So, how do they help us read physical maps? Isolines are lines that connect points with the same value. They can representing things like elevation, temperature, or rainfall. By connecting these points, isolines turn scattered data into clear patterns. This makes it easier to see how features like mountains or valleys change across an area. Let's start with contour lines, which are a type of isoline. These lines connect points of equal elevation. When contour lines are close together, it means the land is steep. If they are farther apart, the land is flatter. This visual representation helps students understand the terrain's shape without needing a three-dimensional view. Isolines also show gradients, which are changes in value over distance. For example, isobars connect points of equal air pressure. This helps predict weather patterns by showing areas of high and low pressure. Similarly, isohets connect points of equal rainfall, giving insight into how precipitation varies across a region. One important thing to note is that isolines do not cross each other, except in rare cases like cliffs. This consistency makes it easier to read and interpret maps accurately. Students can rely on this feature to understand continuous data on a flat surface. From an interactive learning standpoint, isolines make geography engaging. They allow students to visually explore real-world patterns. Activities like drawing isolines from data points or interpreting isoline maps can turn abstract numbers into tangible geographic stories. For instance, students can observe how mountains affect rainfall by looking at how isohets curve around high elevations. In summary, isolines help read physical maps by connecting points of equal value. They reveal patterns in elevation, temperature, pressure, and rainfall. They show the shape and steepness of land through contour lines. They illustrate gradual changes across a landscape. By making complex spatial data easier to visualize, isolines support interactive learning. This approach links map reading to real environmental features, making geography accessible and engaging for K-12 students.